Well, the next thing we're going to look at is called the average rate of change. It's really simple. The average rate of change between any 2 points on the graph of a function, like we have down here, I'm going to use this point and this point. The average rate of change from this point to this point is simply the slope of the line containing those 2 points. That's all it is. So, is the slope of the line containing the 2 points. That happens to be called a secant line when you do this, when you connect 2 points on a function with a straight line. So what we're looking for is this slope. The slope of this line, I'll write it as a line segment. Okay, so we'll see, what is this point? This point looks like 1, 2, 1, 2, looks like 2, 2. Now this one, I don't have it numbered here, so 1, 2, 3, 4, 5, 6, 7, 8, 9. 9, comma, 1, 2, 4. 9, comma, 4. So let's find the slope of that line. I'll say 4 minus 2. That's the difference in the y's. This y minus this y. And then this x minus this x gives us 9 over 2. 9 minus 2. So we get 2 over 7. This is the average rate of change from here, this point, to this point. Even if the function went down and up and down and up and down and up and down, as long as it started here and ended here, the average rate of change is like you're walking up this slightly inclined straight line, and the incline or the slope is considered the average rate of change. Okay, so let's give it a formula. Let's give the average rate of change a formula. If this is one ordered pair, and notice instead of writing it as x1, y1, x2, y2, this is x1, f of x1, x2, f of x2. Just another way of writing it. Okay, if those are two distinct points, then the average rate of change, that's what we're going to write the formula for, from x1 to x2 is simply, I won't put m equals, but it's f of x2 minus f of x1 all over x2 minus x1. So it should look just like the slope formula, only instead of y2 minus y1, we said f of x2 minus f of x1. Same thing. All right, let's do an example. Find the average rate of change of this function, f of x equals x cubed, from 0 to 1. All right, well, what we need, we're using this. So we're going to say f of x1, let me write, or f of x2, I'll go ahead and rewrite this, minus f of x1 all over x2 minus x1. So f of x2 is f of 1 minus f of 0 over 1 minus 0. As simple as that. Now we just need to plug this in, find out what these numbers are. Well, f of 1. If f of x is x cubed, f of 1 is 1 cubed. So that's 1. And 0 cubed is 0. So that's it. That's the average rate of change. So that means that when you travel from x1 to x2, on this function, if you drew the straight line from those 2 points, it would have a slope of 1. All right. Now let's go from 1 to 2. And if you're thinking, well, these are distance 1 apart and these are distance 1 apart, so it's going to be the same number. Well, no, it's not. And let's show that. This would be f of 2 minus f of 1 all over 2 minus 1. I didn't write this out again. I didn't write out the formula for it. But that's x2, that's x1 in parentheses, and then x2 minus x1. Okay, so this time we have f of 2. Well, that's 2 cubed minus 1 cubed over 2 minus 1. So that's going to be what? 8 minus 1 over 1. 7. They're coming out whole numbers here. You can think of this as the slope being 7 over 1 if you want. Go up 7 to the right 1, up 7 over 1. All right, let's do one more on this, one more example here. So I want f of 1 minus f of negative 3 all over 1 minus negative 3. So what do we get? F of 1 we know is 1 cubed minus negative 3 cubed over 1, that's 1 plus 3, which is 4. Okay? So that gives us 1 minus, and what is negative 3 cubed? Negative 3 times negative 3 times negative 3 gives us a negative number, negative 27 over 4. That is 1 plus 27, 28 on top, 28 over 4, 7 again. And trust me, this was absolutely coincidental. Don't think it's always going to work out like that. It might be fun for you to draw this graph, y equals x cubed, and connect these 2 points, and connect these 2 points, and verify that they have the same slope, which they will, of course. All right, one more to finish up this video. Suppose that x2 is written in terms of x1. Call it x1 plus h. What is the average rate of change of f from x1 to x2? It's very simple. We just plug it in. It is. I'm gonna write down the equation one more time to make sure we all get it. That's what I'm looking for. But what is x2? We're going to get x2 out of this picture. x2 is x1 plus h, right? So I'm going to replace x2 with x1 plus h. F of x1 plus h minus f of x1 over x2 is x1 plus h minus x1. So again, I replaced x2 with this right here. And what does that denominator equal to? What is it? How does it simplify? The numerator is f of x1 plus h minus f of x. Well, we have an x1 and a negative x1. They just cancel out. So this is the answer, and that should look familiar from a previous video, from a previous section. This is the difference quotient of the function f.